With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with a question which says the internal energy of the system remains constant when it undergoes. So there are four options that has been given and we need to check for which of the process internal energy remains constant. Alright, or we can say change in internal energy becomes zero. So now for the first case we can see the case has been given as a cyclic process, and for cyclic process we know change in internal energy is zero because internal energy depends upon temperature, and we know for a cyclic process the initial state and the final state is the same. Alright, so we can say the temperature for both the initial and final state are same. That's therefore we can say delta T is 0, and if delta T is 0, so we can say delta U will be 0, and if delta U is 0, so we can say internal energy final will be equals to internal energy initial. So this is the right answer. Now let's move on to the second case, that is the isothermal process. So for isothermal process we know change in temperature is 0. Alright, and if this is the case we can say internal energy is given by the formula that is change in internal energy, that is delta U is nothing but it is NCV or delta T, and here we can see delta T is 0, therefore we can say delta U, that is change in internal energy, will also be 0. And if this is the case, so therefore we can say internal energy final will be equals to internal energy initial, and this option is also the correct option. Now let's move on to the third case for adiabatic process. So for adiabatic process we know heat supplied is 0. Alright, so we can say it over here. For adiabatic process, for third case we are taking, for adiabatic process Q is 0, and by thermodynamics first law of thermodynamics we can say if Q is 0, by first law let's write the expression. We can write delta Q is equals to delta U plus W. So this is what the expression for the first law of thermodynamics looks like. So we can say heat supplied is 0 in this case, therefore we can say work done, or we can say change in internal energy will be equals to negative of work done. So in this case we can say change in internal energy is not 0, so we can say it is not constant, or we can write this way in internal energy final is not equals to internal energy initial. So if this is the case we can say this option is incorrect. Alright, so internal energy does not remain constant for adiabatic process. Now finally we have to check for any process in which the heat given out by the system is equals to work done on the system. So we have to follow the convention for this part of question. So convention is that, let's write it over here, work done is taken as positive, or we can say work done by system is taken as positive over here, and we can say work done on system is taken as negative. And similarly for heat we can say heat supplied to system is taken as positive over here, and we can say heat rejected by system to the surrounding is taken as negative. Alright, so this convention we have to be careful with. So if we now these are the convention and we will apply it in the first law of thermodynamic case. So we can say by first law of thermodynamics we can say Q, that is heat supplied, is equals to delta U, that is change in internal energy, plus work done. And now in the question it's been given for any process heat given out by the system is equals to work done on the system. Heat given out by the system, that means heat rejected, it should be taken as negative, so we can take it as negative Q. And work done by the system, is taken to be as work done on the system, sorry, so work done on the system is taken to be as again negative. All right, so and plus of delta U, and it's been given that this both the terms, that is heat supplied, uh, heat rejected by the system is equals to work done on the system, so both terms are equal, so we can cancel it out. So therefore we can say change in internal energy will be 0 over here, and if this is the case, we can say internal energy final will be equals to internal energy initial. So this option is also the right answer. So first, second and fourth option is correct, and third option is incorrect. So I hope you have understood the concept well, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.